Here, I is given. The I to the power of 1 is I, as you know, from the powers of integers. So I squared, we said that in the beginning, in the definition, we said that I squared is -1. And this one will help us to find the other powers. Then I cube. What is I cube? I can write I cube as I squared times I. So we know that I squared is -1, then it will be -1 times I, which is -I. Okay? And I to the power of 4, how can I write I to the power of 4? How they have found that I to the power of 4 is 1? I can write it as I squared times I squared, or you can write like I cubed times I. Any of them you can choose, but I squared times I squared is easier because we know that I squared is -1. So it will be -1 times -1, which is 1. So I to the power of 4 is 1 always. Then when you're coming back, when you're continuing I to the power of 5, you can use the I to the power of 4 times I. Now I will use I to the power of 4 mostly because I know that I to the power of 4 is 1. It will help me. So 1 times I will be I. And I to the power of 6, I can write as I to the power of 4 times I squared. What we said for I to the power of 4, we said that it is 1. For I squared, we said that it is -1. So it will be I'm saying -1. And it continues like this. I to the power of 7. Again, I can write like I to the power of 4 times I cube, which is 1 times, what is I cube? -I. Then the result will be -I. And the last one, I to the power of 8, is I to the power of 4 times I to the power of 4. And it is 1 times 1 is equal to 1. So can you see something in this table? How it goes? For example, I -1 minus I, 1. I -1 minus I, 1. So if you will continue to find the I to the power of 9, what it will be? What do you think?
I.
It will be I. Let's see. I to the power of 8 we know, times I. I to the power of 8 is 1. 1 times I will be I. Then what do you think? What will be I to the power of 10?
-1.
-1. And if I will continue, again 4 units, again it will continue the same. In every 4 steps, let me say, or 4 units, it repeats itself. I -1 minus I, 1. I -1 minus I, 1. Always it will continue in this way. Because of that, in the other higher units, higher powers, we'll use I to the power of 4 to find our, or 4, the number 4, to find our power, what is equal to, because in every 4 powers, it repeats itself. If you have written this one, if you will write in this way, it will be more helpful for you. I can wait, or I will continue to show you how we are finding the other parts. Do you have any question here?
It's clear till now.
It's clear, okay. You understood the logic of this, how I have separated them. I cannot talk.
Yes.
I am a bit, okay. So I am continuing, if it is okay. Here it's like a game. You can take one of them to put in a look. When I am putting here, it's correct. So I have the I here. So what do you think? How we will find I to the power of 14? What will be? What do you think? I to the power of 14. What we said? We said that in every 4 steps or
-1.
it will repeat. So what I will do to find it, I will divide 14 by 4. What will be when I will divide 14 by 4? 3. 3 times 4 is 12. The remainder is 2. What it gives to me, this 2, it gives to me that, look, I can write I to the power of 14, or let me show you here, remind you this one. When you have a division with remainder, can I write this 14 as 3 times 4 plus 2? Yes?
Yes, we can.
So if I will write the same thing for the power, 3 times 4, or let me write 4 times 3 plus 2. How I can write this one? This is I to the power of 4 times 3 times I squared, yes? Can I write like this? Can I separate because it's addition here? I can separate multiplication. This one is as I to the power of 4 cube times I squared, yes?
Yes.
So what is I to the power of 4? What is, we said? It is 1.
1, yes.
So 1 cube is 1 again. What is square? What we said? I squared is minus
-1.
minus 1.
Right? Yeah.
1 times minus 1
-1.
minus 1. So I to the power of 14 will be minus 1. So I'm taking minus 1 and I will put here. I showed you here all the details. You don't have to write always all the steps. For example, I showed you why it becomes like that. Because look, if I will write, what is the remainder here? 2. So directly I can write I to the power of 14 is equal to I square. I am taking the remainder. So I square, what is I square? It's minus 1. So the result is minus 1. According to this, what will be I to the power of 23? I to the power of 23. When you will divide 23 by 4, what will be the remainder?
Teacher, we all divide them by 4?
Yes, always. Why? Because I to the power of 4 is 1. We are trying to find that 1 there, to cancel that part. When I will divide 23 by 4, what will be the remainder?
8. No. No, wait. So teacher, it should be 5. Yeah, okay. It should be 5
Okay.
here and then 3.
3. So the remainder will be 3. 23 divided by 4 is 5. 5 times 4, 20. The remainder is 3. So I can write directly that I to the power of 23 is equal to I cube. And what is I cube? We gave the first section
Minus I.
minus I. So I to the power of 23 is same as minus I. So I will take minus I and I will put here.
So it's also the remainder.
Yes.
Okay.
Yes. So I cube is minus I again. What about I to the power of 12? 12 is divisible by 4. So there won't be any remainder, yeah?
Yes.
It's 1.
So what will be the result here?
1.
1. Yes, it will be 1 because when you will do this one, let me write here, I to the power of 12, same as I to the power of 4 cube. Yes? So again, because this one is 1, 1 cube is 1. But also you can think like when you are dividing 12 by 4, because it's divisible, there is no reminder, it is 1 directly. What about I to the power of 31? Can we do it directly without doing these operations? 31 divided by 4, what will be the remainder?
Teacher, 3.
3. So you have I cube. What is I cube?
I cube minus I.
Minus I. So here
Yeah.
it is the minus I. What about I to the power of 5? Look here, you have
Yeah.
both of them. It's I. There is no any other chance. It's okay. Did you understand the logic?
Yeah.
It's not that hard. Are you writing? I can wait or I can continue.
Just a minute, teacher.
Okay. It's okay?
Yes, teacher.
Okay. Now, reduce each expression to its simplest form. Look the powers here. They are 1,940, 1,713, 3,498, 1,879. So here, if we'll try to divide by 4 in normal way, all the number, we'll have a long division, yeah? 1,940. But if you will remember the divisibility rules, what is the divisibility rule by 4? Here, it's given. If the last 2 digits of a whole number are divisible by 4, then the entire number is divisible by 4. So you don't have to divide all number, this huge number, by 4. You will take last 2 digits, 40, for example. I'm right.
So we'll only work with that number? The last
Yes.
digit? Okay.
Yes. So 40 is divisible by 4?
Yes, it's 10.
It's 10. So there won't be any reminder. So what will be the I to the power of 1,940? Because there won't be any reminder. Like we did here in 12. Or was it? I gave different numbers.
Will it be 1 or no? I'm
It
not
will
sure.
be 1.
1, yeah, okay.
Because there won't be any reminder.
Yes.
Or you can think like this. What we're doing, I am dividing 40 by 4. And it's 10. And there is no reminder. What we were doing, we were taking the reminder. So I can write this one as I to the power of 0. So what is anything to the power of 0? It is 1.
1.
Also like this you can do.
Uh-huh.
What about in B? I have I to the power of 1,713. We will take only
13.
13. When I will divide 13 by 4, what I will get?
You have 1 as a reminder.
We will have 1 as a reminder. So this one will be I to the power of 1, which is,
Yeah.
okay. Now in C, I will give you time to do by yourself. And in D, 29. Stephanie?
Should we do D too?
Yes, also D.
Teacher, I saw C. And
Okay.
-1.
What you
Because
couldn't hear you? Minus?
I think it's -1 because the remainder is 2. And
Okay.
equals -1.
Okay, so let's do 98 you did divided by 4.
It's 24.
It's 2, 8, 18. As you said, 24, 16. So the remainder is 2. Because remainder is 2, it will be I square. And then, as you said, it is -1. Okay, thank you. Sarah, do you want to do D? We will take last 2 digits. Yes? Your voice?
Yes, it's just a moment because I am doing it.
Okay, hi there.
Teacher, the reminder is 3.
The remainder is 3. Let's do it together. How you did? 1, 4, 39. So 9 times. 36. And the remainder is 3. So it will be I to the power of 3. What is I to the power of 3?
Minus I.
Minus I. So I to the power of 1879 is equal to minus I. Okay? Clear?
Mhm.
Yes,
It's not hard. Yeah?
it's clear.
Yeah, it's clear. Okay. So you have written them. I can continue. Yes or not?
Yes, teacher.
Okay. Now we don't have Salman and Joanna in this class who was answering. So I'm waiting from you. Yes, no. Okay.
Okay.
Now we have the negative powers. Again, we'll use the same thing. Okay. I will give you time a bit to try to solve, to find something, and then we'll talk, okay? Let's see what you will do with the negative powers. How you will start to solve this one? For example, what you did? Because it's negative power.
We divided by 4.
Divide by 4, yes.
So it's, if we divide it with the -2, it's -24.
Mm-hmm.
We have no remainder.
Mm-hmm.
And
And
there I am.
it becomes 1. Huh? Here,
Comes
yeah, it's I to the power of -90. Do you remember when we had negative powers? We were writing them as 1 over something. Do you remember this? Second.
Not really.
when you have a to the power of -n is always, I mean, when you have negative power, we are writing it as 1 over a to the power of. Always like that. And now here also we'll use that one. And what you said, when you divide 96 by 4, there is a reminder. 8, 16, 4, 16, 0. So this part we have
It will be 1.
1, so it is 1. Okay. For B, let's see how it will be. Again, you will divide by 4. Again, I will write 1 over I to the power of 155.
Yes, teacher, this has the remainder 3.
This has the remainder 3, so it will be 1 over I.
Yeah.
What is I cube?
Minus I.
Minus I. 1 over minus I will be the.
So we leave it like that?
Here in the complex numbers, with the I, the things with the I, you cannot leave, like, do you remember in, how to say, in square roots? Do you remember we were not leaving in denominator the square root?
Mm-hmm.
What we were doing? For example, I have 1 over root 2, and I was doing not to leave it here like radical expression.
So we multiply 2 and 2 to the
We're
2 roots?
multiplying.
Yeah, okay, I got reminded now.
Okay, so it becomes root of 2 over 2. So also here, not to leave here the I will multiply with I. Why with I? To get I squared there, okay?
Okay.
When I will get the I squared, when I will multiply by I, it will be I over minus I squared. Yeah? What is
Yes.
I squared?
I squared minus 1.
Minus 1. This minus is there already, and minus 1. Minus times minus will be plus.
Plus.
I over 1 will be I. Okay?
Okay. Yeah. Okay.
I'm giving you a bit in a longer way to make it like, to give you in a way that you know? Because you can write it in another way with a modular, but it will be more complicated for you because of that. I am not giving in that way, okay?
Okay, teacher.
And with this, if we have learned this one, that we are not leaving the I in the denominator, let's do this C. Let's see how it will be. I to the power of minus 2,361. Again, I'm writing like over.
Yeah, we have 1 as reminder here.
Here you have 1 as reminder, so it will be 1 over I. Here, I to the power of 1. Then what we'll do? Again, we'll multiply by I.
Yeah.
And it will be I over I square. What is I square?
Minus 1.
Minus 1. I over minus 1 will be
1.
I. Okay.
Yes.
The others, girls, it's okay?
The negative part, teacher, is kind of more confusing.
Yes, it's a bit it's a bit more confusing, yes, because you know it's not directly, you cannot do it like you were doing in positive ones directly. You have to do these steps. It's only a bit longer solution. What about the last one? Let's see the last one. Elsa, here, look, the thing that we are doing, only firstly we are writing, because it's negative power, we are using this property, and I'm writing it 1 over I to the power of, without minus, 5,130. And what we said, and as divisibility rule by 4, only last 2 digits we are taking.
The reminder is 2.
So 30 divided by 4 I'm doing. What is 7? 7 times 4, 28, and the remainder is 2. And we are taking the remainder, and we're writing 1 over I square, directly the remainder only. And from the first part that we gave the powers of imaginary unit, I square, we said that it is?
Minus 1.
Minus 1, so 1 over minus 1. 1 over minus 1 will be minus 1. Okay? It's only a bit longer solution, but again, dividing by 4, you're taking the remainder. But the important thing is you need to know first 4 powers. I square, I cube, and I to the power of 4. You need to know them, and then we are using always this 4. Okay?
Okay.
It's okay. Can I continue to the next one to see what kind of questions we have?
Yes.
Yes.
Teacher, at the D
Yes.
here we directly got I2, I and
Yeah.
square.
Yeah.
Yes, so we don't need to do the other one.
Yes, because I square is minus 1 and there is no. But if you have this I, like I, only I in the denominator, you need to find.
Make it square. Yeah. Okay.
Now here we have another type of question. I to the power of 4n square minus 8n plus 1. What do you think? What we'll do here? Do you have any opinion about the question?
We need to find them.
How will we find them? We'll equalize to 0 and let's find some n's there. Huh?
We'll start like last year.
Yeah.
Yes.
Quadratic, look, quadratic.
Yes.
There.
That's what it looked so familiar.
No, we'll not find n here. still will not input, I mean, will not put the quadratic. It will come, but not here. So here, girls, what we'll do, we'll write the powers all separately, like what I mean. I have I to the power of 4n squared times I to the power of minus 8n times I. Which property I'm using here? Again, I'm using the property m plus n is equal to a to the power of m plus n is equal to a to the power of m times a to the power of n. Do you remember this? So I'm taking this one, and this one, and I'm writing with the multiplication. Now what I will do, again here, I will try to find a to the power of 4. How it will be, look, here I have 4 times n squared. Here I have minus 8n. Do I have a 4 here, the multiple of 4 here?
Yes.
So what
Yes.
I will do, I to the power of 4 to the power of n squared. Here, which property I'm using? I'm using this property. It's m times n. Times here, what I have, minus 8n. I can write as 4 times minus 2n, yes? So it will be I to the power of 4 to the power of minus 2n. And then because this is I, it will stay as I. Okay?
Okay.
I to the power of 4, what is I to the power of 4?
A 1.
1. So here what I have, 1 to the power of n squared times 1 to the power of minus 2n times I. 1 to the power of anything is 1 to the power of anything is 1.
1. Yeah, 1.
Don't be afraid, tell what you know. 1 to the power of anything is 1. So here I have 1, here I have 1, here I have I. 1 times 1, it's 1, times I, it's I. So the result is I. Okay?
Okay.
Are you writing? I can wait or I can solve B. How you want?
A little bit.
Okay. Now in B, which property I will use from these two? Look, I have here I to the power of 2n plus 1 in parentheses to the power of 2n minus 1. The second one. So it means that I can write this one as 2n plus 1 times 2n minus 1. Is this one familiar?
Yes, it is.
It is, yeah?
Yes.
A minus b times a plus b we had. And we said that this is a square minus b square. So I will have I to the power of 2n squared minus 1 square. And I will have, what will be 2n squared?
Four.
Of 4n
And
square will be minus, I started to write that, minus 1. This is the power. Now again, what I did here, I separated the powers. Also here, I will do the same thing. I will have I to the power of 4n squared times I to the power of minus 1. Did I find the 4 here?
yes.
What I will do, you can write I to the power of 4 n squared times this one is, again, I will write like I to the power of minus 1. Now this part, what is this part? Because it is I to the power of 4, it is
1. Was it?
1. So this part becomes 1. Then I have 1 times I to the power of minus 1, which is I to the power of minus 1 again. But what we said when we had negative power, 1 over I will write.
Okay.
And then I will multiply by I will get I over
I square is
squared.
minus 1.
Yes, and then it will become minus I. Okay.
It's okay.
We have less than 1 minute. It will close itself. So see you if we cannot talk. And please check in the weekend a bit what we have done, not to forget. Okay.
Okay, teacher.
Okay.
Thank you.
Bye.
Bye.
See
Have a
you.
great day. Have a nice weekend.
Thank you.
Bye. Have a nice weekend.
Thank you very much. Bye.